Welcome. So now we're going to be identifying more domain and range. Right? So domain are the possible x values. Range is the possible y values. Right? Let's do domain first. So and we'll do this in both set notation and interval notation. So when you're looking at domain, right, you look left to right. Right? So notice if we look to the left, right, this point here is the farthest left. Right? There's nothing further left than that. It's a point, not an arrow. So it's going to start there. Now let's look at the other end of the function. The other end is over here. There is an arrow. Right? It is not a vertical line that is stopping at any point. Right? It's just growing faster on the y than the x, but it is going to keep moving out. So when you see the arrow, it's going to keep moving in that direction it's heading. So that arrow shows that the function is going to keep moving to the right, and it's going to keep moving down. So we have a starting point, and then the function is going to keep moving to the right. So the domain, actually let me write the word domain we'll do interval first. In interval notation, we have a bracket because that is a point. That's a starting point. We do reach that point. All right, our function does reach -5. So interval notation, the domain is -5 to infinity. It's going to keep on moving to the right. In set notation, we would write that as brace. Sorry, it's not the greatest looking brace in the world. X such that x is greater than or equal to -5, and then close the set. All right, now let's look at the range. All right, the point that is well, we can't really point to the lowest point, right, because our graph keeps going down, but we do have the highest point. So the highest point is right here. Right, that is the highest point. And then the function just keeps on moving down, right? So this arrow our function here is heading to the right, and it's heading down. Right? So for the range, the lowest point is going to be -infinity. It's just going to keep getting smaller and smaller. Our highest point is to the left there. The highest point is right here at 5. So in interval notation, the range is parentheses, so go low to high. Right? So we're not going to start with the point that's our highest point. We're going to start with the lowest point, which is -infinity. So -infinity, and then we stop at 5. Right? That is the highest point. Right? Our graph does not go above 5. It stops there. We use a bracket at 5 because we actually go through the value 5. In set notation, this would be, embrace, x such that x is less than or equal to 5. So it's all the values that are less than or equal to 5. Right? So look to see whether you have a point or whether you have an arrow. State the domain and range for the graph. All right, we've got arrows on both ends. I'll highlight the arrows on both ends. All right, so on the x, our function is going to, I forgot to put the highlighter away. Our function is going to keep moving to the left. Our function is going to keep moving out to the right. So let's do the domain. That's your x values. So in interval notation, that would be negative infinity to infinity, because it's going to keep moving in both directions. In set notation, that would be x such that x is a real number. And we'll use our symbol. So this stands for x is an element of the real numbers. It could be any number. That's how you write it in interval notation, negative infinity to infinity. How you say it in set notation, x such that x is a real number. Right? The only numbers on the coordinate plane are real numbers. And then the range. All right, so now we have a low point, right? Our graph turns around. We have a vertex there at -3. That's the lowest point. And then it just keeps moving up, right? So the range in interval notation is, we're going to use a bracket because we go through -3, that's the vertex, -3 to infinity, parentheses for infinity. In set notation, x such that x is greater than or equal to -3. And there we go. If it helps, use a ruler or something to help you see, okay, here's the lowest point. All right, I start there. And then look, do you have arrows? Does it stop or do you have arrows? Arrows means it's going to keep on going. All right, let's find the, this one just says find the appropriate domain. So we'll just find domains on this one. All right, so we have a starting point. So we're looking at the x. Actually, you know what? Let's do domain and range. But maybe we'll just do it in interval notation, right? Because we don't have too much space on this page. All right, so if we have a starting value for our domain, right? Our graph starts at the y-axis there. It starts at the origin. But we have an arrow over here. So it's going to keep on moving. So in interval notation, the domain is, oops, sorry, that should be a bracket. We go through 0, right? We have, it's hard to see because I wrote over it. But you can see there is a point there, right? So the domain is 0 to infinity. It's going to keep on moving in the positive direction. The range is very similar to the domain, right? So I'll use a highlighter. Right, so that's our lowest x. That's our lowest y too. Right? So notice that there's no points below the x-axis. And we do go through the point 0, 0. So the range is 0 to infinity as well. Right? Positive numbers for both the domain and range. Notice the whole graph is in the first quadrant. All right, let's take a look at this one. All right, so this actually has the exact same, one of the reasons I want to do domain and range is this graph has the exact same domain. Notice there are no values on the negative side, right? We start at 0 and we're moving in the positive direction. We're moving in the positive direction for x. We're moving to the right, so that's the positive direction. So the domain is 0 to infinity. But notice that for the range, for the y values, we are, oops, I wanted to switch colors. We are below that line, right? So we are negative values for y. So the range is negative infinity to 0. So it's just the negative numbers. And this one is already, I already have the domain and range on there, and I think it's in your notes. So find the domain and range. We have there are arrows on both sides of this graph. Right? I have no starting, I don't have a starting point, right, where the graph is just moving in one direction. I have arrows on both sides. You can clearly see that the graph is moving out to the right and to the left. It's also moving up and down. So the domain and range are all real numbers for both, right? That graph will eventually, that function will eventually get to every number on the x and every number on the y. It's just going to keep moving to the right and left. It's going to keep moving up and down. All right, so we're going to do these 6, and they are similar to some questions that you're going to do on a worksheet. We are only going to do this in interval notation because we only have so much space. We'll also review whether these are functions and whether these graphs are what's called discrete or continuous. I think this is just a little line, yeah. All right, discrete or continuous means, so a continuous function means that it doesn't start and stop. It just keeps going. There are no breaks in the graph. You can see this graph has a big break in it, right? We've got part of the graph at -3 and part of the graph at 2. So this is discrete, not continuous. The domain, so that's your x values. You notice that we have just x, we have the x there and x there. We literally have only 2 x values, right? We don't go through all the x values. We have 1/2 of the graph going through x equals -3 and 1/2 of the graph going through x equals 2. All right, so the domain is just going to be 2 values. Because it's just 2 values, I'm going to actually write this one in set notation. All right, there's actually going to be 2 I put in set notation. We'll do the others in interval notation. This would be easier in set notation. All right, so the domain is x such that x equals -3 or 2. All right, those are the only x values. The y is even smaller. Actually, the y, I'm sorry, the y, though, is opposite, is everything. Sorry, I'm thinking of another graph. The y is absolutely everything, right? Because we have part of our graph going down, we have one part of our graph going up. All right, so I guess because I did this one, it really doesn't make much of a difference whether I write it in interval notation or set. I guess I'll write it in set because I wrote the domain in set. So this would be y such that y is an element of the real numbers. Oops, come on. And is this a function? We'll use our little line to figure that out. So let me go like that though. A function has to pass the vertical line test. Right? So if there is 1x for every y, it means that if I have a vertical line, I will not pass through the function more than once. Well, you can see, of course, this does not work out. I pass through it many times. I have 2 vertical line segments, right? When x is -3, I can be anything from -infinity to 2, and when x is 2, I can be anything from 2 to infinity. Right, so we have all the y values covered between those 2 parts. However, this is not a function. Right? I have many y's for the same x. So there we go. All right, let's look at this one. Discrete or continuous. Right? There are no breaks in this graph. I have a starting and an ending point, but I have no breaks. So this is continuous. We're going to do the domain this time in interval notation. Our graph starts here and ends here. This is the whole, sorry, that line's not very straight. This is the whole domain, right? So we start at, what is that, 1, 2, 3, 5, negative 5. We start at negative 5 and we end at positive 5. We have an open dot here on the left here, which means we're not going through the point negative 5. So I'm going to use a parentheses, negative 5. Sorry, the orientation's a little off and it's making some of my things not look right. Like that negative. There we go. And then we go to all the way to 5 and the graph ends and point is filled in, so that would be a bracket. The range, the graph starts here and ends here, right? Our entire graph is contained in between those two lines there. So the lowest y value our graph goes through is negative 2. And although it's an open circle on one side, it's got many other places where it's going through negative 2. So this would be a bracket, negative 2, 2. And then the highest value is 2. And a bracket there too. You have a whole little linear section there. And then is it a function? Well, if I have a vertical line, I only go through one point at a time. So yes, this is a function. All right, let's look at number 3. It is continuous. There are no breaks in our graph. There are arrows at both ends. They are going to keep moving to the left and keep moving to the right. So the domain is negative infinity to infinity. They're going to keep moving down, keep moving up. The range is also negative infinity to infinity. If you have two arrows at the ends of your function and they're moving in opposite directions, your domain and range are going to be negative infinity to infinity. And is it a function? Well, yes. Only one point is the line is only going through one y value at a time. So yes, that is a function. Discrete or continuous. This is continuous. There's no breaks in the graph. The domain, we've got arrows on both ends that are going to the right and to the left, right? So this graph is moving to the left on one side, to the right on the other side. So the domain is negative infinity to infinity. But there's only one y value. Matter of fact, this is the equation y equals 3. So if you're the equation y equals 3, your range must be 3. And it does get a bracket. And since it's one single number, it's just that value. No matter what, y is 3. It is a function. It definitely passes wherever that vertical line went to. It definitely passes the vertical line test. I only go through one point at a time. It's a horizontal line, right? I don't have two y values for the same x. And moving on. All right, discrete or continuous, it's points, right? They're not connected. It's discrete. That is not continuous. The domain, we'll put this in set notation because it's just going to be a bit too big. It's just going to be the x values for the points. So I've got the point, I've got negative 3. Oh, it's not writing very nicely. Here, I'll write it here and I'll move it in the right spot. Negative 3, negative 2. We've got 1. We've got 2 and then 5. All right, let's see if I can squeeze it in over here. Sorry, that weird diagonal line is supposed to be a -1, or negative. That's in front of the 2. All right, so that's the domain. It's the x values of those points. Right? And then the range is the y values of those points. And in fact, maybe just to make things easier, I'll write these points out. This was -3, 1. We have -2, 0, 1, 4, and 5, 1. So the range is the y values I just wrote down. And so we've got, let's see, we have, oh, there we go. I can't seem to get it to fit on the line. I'll write it up here and I'll move it into place. All right, we have 1, 0, and 4. I don't need to write it twice. Maybe I'll put it in order. 0, 1, 4. You don't need to write the 2 ones. Once is good enough. Let's squeeze it into place. I guess that you can see that good enough. All right, and oh, I forgot one of the points. I didn't even see him down here. We have 2, -4. I totally missed him. Well, no, I got him. I wrote him down for the domain. I missed him for the range. All right, so let's just squeeze in -4. All right, so let's see. 4 and -4. There we go. So 0, 1, 4, -4. Notice that there is only one y for every x, right? -3 is matched with 1, -2 is matched with 0, 1 is matched with 4, 5 is matched with 1, 2 is matched with -4. You don't have any x values matched with more than one point. It is a function. And then the last one here, right? It is continuous. There's no breaks. The domain, right? Our graph is only moving in that direction. Right, so we have, it's going to keep heading to -infinity, but it stops right at 4. So that'll be a bracket for 4 because we do go through 4. Range, it's just the positive values. So bracket 0 to infinity, and it is a function. If we take our line here, we only go through one point at a time. So that is a function. And I think that is where we're going to end. Yep, that's where we're ending. So thanks for watching. Bye for now.